Hello everyone, my name is Apurva Manaraj and I'm excited to share my final project for the Duke AI Product Management Specialization. My project focuses on predicting ATM cash replenishment needs using machine learning. Let's start with the problem that I'm trying to solve. Banks usually follow a fixed schedule to refill cash in ATMs. The issue is these schedules don't always match actual customer behavior. Sometimes ATMs run out of cash unexpectedly, causing inconvenience for customers and requiring emergency cash runs, which are expensive. Other times, cash just sits there idle in machines where it wasn't really needed, tying up money that the bank could use elsewhere. So the key task here is to predict if an ATM is at risk of running low on cash in the next 48 hours, so operations managers can plan refills better. My task analysis showed that users don't want to stare at huge tables of data for every ATM. What they really want is a simple way to spot the few ATMs that might be a problem. They need quick insights, not raw numbers. So my main takeaway is that simplifying the task flow, like giving users a dashboard that flags only high-risk ATMs, will save time and make their jobs easier. Here's how the user experience will work for my product. Operations manager would log in once a day to check a dashboard. The dashboard shows a ranked list of ATMs with each ATM given a percentage risk of cashing out in the next 48 hours. The higher the percentage, the higher the priority for refilling that ATM. As for inputs, users don't really have to enter anything manually. The model automatically uses historical withdrawal data, transaction patterns, and even local event calendars that might affect cash demand. I'm also designing a feedback loop into the system. Users can mark predictions as incorrect, for example, if the model predicted a cash out, but the ATM stayed fine. That feedback goes into the system, back to the system to help improve the future predictions. Transparency is important. I want users to trust the model. So each prediction comes with a short explanation, like this ATM is showing higher withdrawals because of a payday pattern, or there are local festival coming up. Communicating uncertainty is another part of the AI UX. Instead of just saying yes or no, I'm showing a probability like there's a 72% chance this ATM will cash out. This way, the operations team can weigh the risk of uh, the output instead of relying on black and white answers. Now, let's talk about privacy. The data I'm using is mostly aggregated ATM level transaction volumes. It does not include individual customer names or account numbers. However, even transaction data can be sensitive because it might reveal cash flow patterns that could be misused if exposed. To protect privacy, I'm planning several safeguards. I'll aggregate data so that we never store individual transactions tied to specific customers. I'll also make sure the data is encrypted both when it is stored and when it is transmitted between systems. Access to this data will be restricted to only those who need it for their job. From a legal perspective in India, the new data protection bill would apply if we dealt with any personally identifiable information. If we expanded this product into Europe, we'd also have to comply with GDPR. Even though ATM data might not always identify specific people, regulators could still classify it as personal data if it could be linked back to any individual indirectly. So my approach is to stay cautious, limit data usage to only what's necessary, and document exactly how data is collected and processed. Let's move on to ethics, which is crucial for any AI product. One major risk that I see is regional bias. Some ATMs in lower income or rural areas might have fewer transactions historically. If the model relies only on past data, it might underpredict cash needs in these locations. That could mean those areas get neglected, which is unfair. Another risk is data drift. Patterns of cash withdrawals can change quickly, for example, if digital payments become more popular in certain regions. The model has to adapt or it'll start making wrong predictions. To ensure fairness, I'll regularly test the model's performance across different regions and user demographics to make sure predictions are balanced. Accountability is also key. Even though the model makes predictions, final decisions about cash refills remain with human operations managers. Everything is logged so we can go back and check why a certain ATM was flagged or not. Transparency is built in through explanations for each prediction. Users don't have to guess why the model flagged a specific ATM. They can see the factors contributing to that decision, like unusual transaction spikes or nearby events. My goal is to build a system that supports humans rather than replacing them, and to ensure decisions are fair, explainable, and responsible. Here's a quick mock-up of what the dashboard might look like. The dashboard lists ATMs along with their predicted risk of cashing out. For example, ATM 4532 shows a 72% risk with a note saying there's been a spike in withdrawals due to payday and a local event coming up. Users can click on any ATM to see details like recent transaction volumes, last refill date, and any special factors driving the prediction. The point is to give users a clear, actionable view rather than overwhelming them with data. Even a simple table like this can make a big difference for operations managers, helping them focus only on ATMs that truly need attention. So, to summarize, predicting ATM cash replenishing using machine learning is practical, high impact idea. It solves a real business problem, improves customer satisfaction, and helps banks optimize cash management costs. My solution is designed with user experience in mind. It's transparent, provides explanation, and communicates uncertainty clearly. I've also addressed privacy and ethical concerns, ensuring compliance with relevant laws and aiming for fairness and accountability in predictions. The next steps ideally would be testing this solution with real data and refining it based on user feedback. Thank you.